Congratulations. Okay, oh, they're on there. Okay. Okay. Hello. Good morning. Hello. Oh, okay. That one works. Okay. Yes. Good morning. Bonjour. Got your attention at least. So my name is Mona Nimmer. I'm the Chief Science Advisor to the Government of Canada, and I'm delighted to be here with two distinguished American-Canadian scientists who are joining me from beautiful British Columbia to talk about big science and big infrastructure and their role both in science advancement but also in international collaboration. So I'm going to start right away. Here with me is uh, Kate Moran, sorry, Kate Moran from Ocean Network, which is based in Victoria. And on my right, you have Jonathan Bagger, who's the CEO of Triumph. And they're both going to tell us about this great organization. So I'll start with you, Kate, and please tell us a bit about yourself and about Ocean Network.
Well, thanks for coming and listening to some immigrants to Canada. I'm the president and CEO of Ocean Networks Canada, which is an initiative of the University of Victoria. And we operate a very diverse system of large ocean infrastructure, monitoring every aspect of the ocean, from earthquakes to tsunamis to whales to sounds to chemistry to physics to even neutrinos that you'll hear about from Triumph. And we support thousands of scientists who use our data that's openly available over the internet around the world. More than 50% of the scientists that use our infrastructure are from outside of Canada, and they use it because we have installed systems on the most diverse range of ocean environments of any other observatory on the planet, from low oxygen environments to spreading centers to subduction zones. And I'm trained as an ocean engineer. My entire career has been applying ocean technology to scientific problems and solving them. And I'm just thrilled to be here to share what we do.
Great, thank you very much. And Jonathan, you tell us a little bit about yourself and about Triumph.
So I'm Jonathan Bagger. I'm the director of Triumph. And my journey is, I started as a particle theorist in the United States, and I've wound up as director of Triumph, which is Canada's Particle Accelerator Center in Vancouver. And Triumph really is the center of accelerator technology in Canada. It was founded to pursue questions in nuclear physics. But what's really exciting to me is that over the years, the lab has diversified and really become a multidisciplinary facility. And we apply those same accelerator technologies to questions that are directly relevant to this conference. For example, we are using our beams to space qualify electronics for satellites which can monitor the conditions of planet Earth. We are using our beams to characterize materials, for example, by inserting lithium ions into batteries to learn how lithium ion batteries work better. And we also are using our technologies to improve human health by making isotopes which can be used both to diagnose and treat disease. So it's really exciting to me how this technology, which was developed for nuclear and particle physics, actually has broad applications throughout society.
Thank you so much. So you started mentioning all the different questions that can be answered through accelerators and all these big machines. I actually paid a visit to your institution, and it's fantastic. So maybe you can tell us a little bit about the sort of blue sky type science or questions that you would like to see answered during your lifetime through perhaps installations like Triumph?
So I can tell you three questions that drive me at Triumph. One is the reason the lab was founded in the first place, which is to understand the nuclear physics that goes into the formation of the elements of which we are made. For example, we've learned through the LIGO experiment about the collision of neutron stars. And those conditions, in the collisions of the neutron stars, the heat and the violence cooks the primordial elements from the Big Bang and makes them into the heavy elements that we see here on Earth. And so we duplicate those conditions in our laboratory to understand the origin, really, of our Earth. But so that's the sort of the fundamental question that drives Triumph. But really, there are two more questions that I'd like to raise as well. One is, can we cure cancer? There's been some very exciting work done recently about using radioisotopes to target tumors and bring the radiation directly to the tumor and kill it through by taking some medicines. And those results that are just coming out now are really very, very exciting, huge remission rates, and so we are deeply involved in the application of isotopes to tumor therapy. And the third question really is, how can we bring all this to market? Canadian labs are very different than US labs. We have a much more fluid line between the pure research and the commercialization. And so Triumph actually makes 20% of its own funding by its own commercial efforts. And those close connections to industry are really very exciting about the Canadian system and allow us to translate our fundamental science into real-world applications quite quickly.
Thank you so much. And if I turn to you, Kate, I mean, oceans, it's a world out there. You know, what are the big blue skies question, if I can say blue skies for oceans, right, that you'd like to see addressed or that keep you up at night?
Well, thank you. I mean, the ocean is 70% of the planet, and we know not enough about it, and only about 10% of it is mapped. But if you looked at the basic questions, we look at spreading centers, where new ocean crust is being formed, and scientists use our data to try to understand the origin of life on the planet. So that's one of the basic questions. We just recently installed a test neutrino observatory where neutrino scientists are trying to understand the origin of the universe. So those are the big questions, but most of the questions that we're looking at are really involved in the biggest issue of our time, which is climate change. And we're trying to understand the impact of ocean acidification on life in the ocean, trying to understand how low oxygen environments will allow life to continue in the ocean. We're also trying to understand how we can assess and predict things like atmospheric rivers. In British Columbia, and people here in Washington State know them as big rainstorms that come and really impact the economy. How do we forecast those? How do we forecast storm surge? How do we forecast tsunamis? And how do we take that information and make it relevant to people who need to make decisions about their own communities, their own infrastructure, and protecting the major economic transfer mechanisms like the port and the airport in Canada?
Well, thank you. These are indeed, you know, big and long-term questions. And they're questions that occupy, I think, a few scientists around the planet, right? So maybe you can, you know, both of you tell us a little bit about the international aspects of the science and the infrastructure that you oversee. You know, what's going on there, why the connections with the rest of the world are important, and so on. So maybe
Sure. Yeah. So as I mentioned at the start, over 50% of the scientists that use our data that's openly available are from outside of Canada. And they use it to try to understand these unique ocean environments, spreading centers, abyssal plains, gas hydrate venting, low oxygen environments. And now we've expanded in Canada to include what we call coastal observatories. These are observatories that we tailor make for mainly indigenous communities, and they sit in fjords. So we're trying to understand the changing coastal environment, but at the same time giving these indigenous communities their own data. And I just want to mention one big, wonderful thing that we just completed in September. Canada, through Ocean Networks Canada, brought together 53 Indigenous communities from around the world to the OceanObs 19 conference that happens every 10 years. And it was the first time that Indigenous communities sat as stakeholders to say to the scientists who do ocean observing, here's what we need to know over the next 10 years. It was an incredible, powerful, and international effort that now brings all of the science community together with some of the many people who need it most.
Well, thank you so much. And Jonathan, as you know, because I told you already before I visited Triumph, I heard so much about you guys in Geneva, at CERN, in the US with the Department of Energy, among others. So tell us a little bit about these connections and, you know, how do you divide the work up, you know, among all these great places in the world?
So in particle and nuclear physics, the facilities are so large and expensive that they really need to be shared globally. Each of the facilities has its own place in this ecosystem, and in fact, Triumph plays its role as well. So at Triumph, we welcome researchers from all around the world. We have researchers from 44 countries who are coming to do their work at Triumph. In fact, only a third of our users are Canadian. The rest come pretty much evenly distributed from the United States and from Europe and from Asia, broadly speaking. And in return, so these researchers are coming to Triumph because we offer them something that other labs can't. But in return, Canadian researchers work abroad as well. And so we are actually a jumping off point for Canadian participation into this global ecosystem. We make components that are shipped to our sister laboratories around the world. That requires really tight coordination between the laboratories. As you were saying at CERN, there's a prime example. The Atlas collaboration in which Canada participates, Atlas has 3,000 collaborators. Each of those collaborators showed up at CERN with some part of this detector in a suitcase, and they put them all together, and it worked. I mean, it's really quite amazing, and it's quite in a very flat structure, but it's really driven by the passion of the scientists who really want to get the science done. And so these facilities not only enable great research to be done across borders, but they also allow a tremendous communication across borders. And I think that's a very important role for us to play in this world now where the barriers to international communication seem to be rising by the day.
Well, thank you so much, and thank you for reminding us that science knows no borders, that science has always been global, and actually is a language for peace and harmony, perhaps across the world. And, I think this is a great message. And you know, you both mentioned international collaborations, the diversity of the folks who come and use your facilities. Maybe you want to tell us a little bit why you think that this, you know, diversity is actually helpful to science. And I'll start with you since I'm looking at you, Kate.
Yes, yeah. Well, diversity is critically important because we need to have all voices. You know, one of the things that I'm passionate about is helping more women in science. If we bring more women, we bring more brains to the table. It's really critically important that we do that. But also diversity in terms of, I just mentioned, communities. I'll just tell a little anecdote. We decided to put a small observatory in Cambridge Bay, Nunavut, which is in the Arctic part of Canada, in 2012. And we thought, we'll put it up there to see if we can have our technology work in the Arctic and see if we can deliver data over the small internet pipe of satellites. And what we didn't realize was that we put a sea ice thickness sensor on it, and right away the town wanted to show the data in the co-op store. And they wanted to show it in the co-op store because they needed to make decisions about taking the shortcut to the airport over the ice or going out to hunt. And that just understanding and opening up our dialogue with the community allowed us now to develop tools for them to have alerts about when they can go on the ice and when they can't. And that just advances technology and advances our scientific knowledge. And in fact, it has now engaged the kids in the community who are now interested in going into marine and ocean science and technology.
Wow, what a beautiful story. I think it's really important that we keep in mind this aspect of the co-development, of the sharing at all stages. And you're absolutely right. It gets us thinking differently and all that. Well, you know, you're both actually born Americans, and I understand that presently you're both dual citizens. Thank you for choosing Canada. So I think you came early, left, and came back in 2011. And in your case, Jonathan, I don't know if there is a previous life, but it's 2014, both from the East Coast to beautiful British Columbia. So maybe you can tell us a little bit about the journey of an American in Canada. Let's start here.
Well, I must. This is a longer story than we have here, but it's actually been very illuminating for me to learn about a different country, a different culture, a different form of government. Because at some level, as an American, I kind of thought of Canada as up there, but Canada has its own values, and really, they're really very powerful values. In particular, the values that I think really relevant to science today includes an immigrant culture. The ambassador to Canada from Italy told me that he had previously been posted in Washington, and he found it very interesting to him because the immigrants in Canada are more recently arrived typically than they had been in the Italian community in the US. And so he felt almost that he was looking back a little bit in time. And so it's a country with an immigrant culture and a recent immigrant culture. And that is very welcoming to the people who come here to do science. So at Triumph, our staff hold passports from 35 countries, and they're working together for a common goal. And to me, that is just awe-inspiring and really makes a statement about Canada and for Canada.
Thank you, Kate. Tell us about the back and forth, back and forth.
Well, I first started collaborating with Canadians when I was invited to go on a ship, the Canadian Coast Guard ship Hudson, when I was a graduate student. And I just fell in love with everybody on board, and it was so welcoming. And I spent when you spend 5 weeks at sea with mostly Canadians, you can't help but decide this is a place where I want to be. So in fact, after I graduated, I went to work at the Bedford Institute of Oceanography, and my career there really took off. I was allowed to do many different things and expand my own knowledge of the ocean through this very prestigious and well-known oceanographic institute that's globally well-known. I then went back to the United States to run what was then called the Ocean Drilling Program. I was a director of the Ocean Drilling Program for several years, and I was proud to do that because it brought a Canadian piece. The Ocean Drilling Program aptly operates what's called now the JOIDES Resolution, that's drilled for many, many decades now for scientific drilling, but it was built in Halifax, so there was a nice connection. And then I spent a little time in Washington further, working in President Obama's Office of Science and Technology Policy, where I learned a great deal about the importance of knowledge for policy making. But I came back here not here to Washington, but here in Canada, because I wanted to roll up my sleeves and really do some ocean observing, because that's how we can understand how the Earth is changing and how we can provide information under this big urgent issue, which is climate change. And the reason, I'll tell you one little anecdote, if that's okay. I interviewed for the job at Ocean Networks Canada, and I flew back to Washington, where I was in the Office of Science and Technology Policy. And in the cab ride back to OSDP, John Holdren, who was then the science advisor, was on the radio, on the noon science program on public radio. And Ira Flato asked him, what is the most important thing in the world to do in terms of science, across all sciences? He said, we need to observe the Earth. And so I had just been in an interview to observe the ocean. I said, I'm going to take that job if they offer me, and I did. And I love British Columbia, and I love being back in Canada. And it's a place where even when the buses are not running, the top of the bus says, "I'm sorry."
Thank you. We love having you too. Jonathan, I think you spoke very powerfully about the international, about your journey. But other than, beautiful British Columbia, the mountains, the ski and everything, what would you say, to someone who wants to have a career, who's starting a career somewhere and is contemplating Canada?
Well, yeah, so I actually never answered the question of how I wound up in Canada. So let me just start with that. And so I had been at Johns Hopkins, and during my time in the administration there, I became very impressed really by the sense of mission and the dedication of the people in the biomedical world at that university. And so as I was thinking about physics, how does that connect to the biomedical world? And all of a sudden this opportunity came up at Triumph, and really what was so exciting to me about Canada is that the barriers between the disciplines at a place like Triumph are low, and the connections, as I said, to the commercial world are strong. And so we were really able to make an impact by taking physics and applying it far from where it really started. So the opportunities in Canada, why move to Canada? Well, first of all, as I said, great equipment and facilities and colleagues, and then a welcoming immigrant culture in the country. I would say the combination is very powerful.
Well, thank you both for this your passion for science, for helping scientists, and you're such great ambassadors for science and for Canada and Canadian scientists as well. So thank you for that. Thank you everyone for listening. Please come and visit the Canada booth. It's right next here, and stay for the next panel because it's also involves some great Canadians who are standing at the back, waiting for us to leave the stage.
And thank you for what you do for science in Canada.
Thank you. And please join us again if you want to hear more about what happens in Canada and about the research scenery in Canada at 3 p.m. I will be here on stage with the president of the Natural Science and Research and Natural Science and Engineering Research Council, best known as NSERC. And you'll hear the rest of our journey in Canada. So, yes, himself an immigrant. You're right, absolutely. So, thank you all, and bonne journée.